Pre-installation hardware considerations. In this video, we'll talk about choosing and evaluating the hardware needs for Linux installation. You have to choose hardware that's supported by Linux, and that's getting easier every day. And you also have to choose hardware that meets your needs and also stays within your budget. So let's get started. When you're considering what hardware to use for your system, you have to keep in mind the purpose of the system. Is it going to be a workstation or is it going to be a server? And for a workstation, what I'm talking about is a desktop computer, like something that you plug your monitor and your keyboard into and you work on it directly. Okay? It might have networking capabilities, but the point is most of your work is done right on that computer directly. And then there's a server, like a web server, an email server. And these, they're always interacted with over the network, whether it's a local area network or an internet or something like that. Okay, so a server you never log on to directly unless you're like a system administrator and you need to do maintenance on it. You're always interacting with that through some program like a web browser, an email client or something. And then you have to ask, what's your budget? And once you determine your budget for this computer, then the game is, to get the best system for your money for the particular purpose. And to do that effectively, you've got to prioritize. And for workstations, probably the most important priority is good input and output devices. So, don't skimp on the keyboard and the monitor and stuff if somebody's going to be working on this computer 8 hours a day in your office. Because any savings you make on the monitor or the keyboard or the mouse or whatever is just going to be counteracted because they're not going to be as productive if the monitor's small or if the monitor's blurry. They're going to get eye strain and they're not going to be able to work for as long hours, that kind of stuff. So the point is, don't skimp on the most important part of the system, which for workstations is certainly good input and output devices at a bare minimum. And then there's servers, and for servers to undergo, to handle a high load, they need to have fast processors, they need to have lots of memory, and they need to have large disks that can transfer data quickly. Okay, so like I said, this is a bare minimum requirements for these two settings. And for workstations, if you're doing scientific computations on your computer, then you'll need more than just good input and output devices. You'll probably need a fast processor and lots of memory too. Or if you're hosting some large database application, you're going to need more than good input and output devices. And then other considerations you have to weigh into this whole thing is just compatibility with the systems that are already in place. So if you're buying some new computer and it's cheap and you're saving money there, but it's not compatible with whatever's in place now, it's going to wind up costing you money because maybe you're going to have to buy new software for it because it can't use the software that you already have, that kind of stuff. And then you have to consider, is your support staff familiar with this stuff? Or are they going to have to take time off of work, off of their regular duties to learn how to deal with this new system that you're getting, even though that's cheaper? Again, the bottom line here is money. And if your support staff needs to go to some training course to deal with this new hardware that you saved money on, is it really a savings then? And you just need to weigh out all of these things, especially if you're in a business environment. Now I want to talk about the hardware that's inside the standard personal computer these days and talk about the choices that are available for each hardware component. And the choices that we're going to talk about here are just generic choices, like the different choices for like the different technologies that are available for that device. And later we'll talk about the specific brand names that are supported by Linux. So first there's the motherboard. And this is the main board inside your computer. When I say board, I'm talking about a circuit board. And it's the main board just because practically everything else in your system plugs into the motherboard. And then there's the CPU, which just stands for the Central Processing Unit. Now the CPU, or the Central Processing Unit, a lot of people call this the brain of your computer. And the reason they call it the brain is because every mathematical computation that's done on your computer is done inside the CPU. Every logical operation or logical decision that's made by your computer is done in the Central Processing Unit. Then there's the memory, or the main memory, some people call it. Some people call it the RAM, which stands for random access memory. It's all the same stuff. The memory is what holds the active programs and the open files on your system. So if you have some file open in a word processor, that open file is in main memory. The program that runs the word processor, the code for that program is also in main memory. So basically everything that's running in your computer, the code for those programs are in main memory. All the files that are open are in main memory. And main memory is electronic storage, so it's really fast, but it also goes away when you turn off your computer. That's why when you've got that file in the word processor in main memory, you've got to save it out to hard disk before you turn off your computer, because when you turn your computer off, main memory is just wiped out. Okay, so when you save it out to disk, the disks are magnetic storage, and magnetic storage lasts a very long time, even when the power's off. Okay, and so this is for long-term storage, for stuff that's not active on your system. The memory and the RAM is for short-term storage for the stuff that is active on your system right now. basically there's two choices for RAM. There's SIM, which stands for single inline memory module, and there's DIMM, which stands for dual inline memory module. And there's variants of each of these, but basically these two are this is the first classification for memory. It just depends on your motherboard which one of these you use. The motherboard's either going to have slots for SIM boards or it's going to have slots for DIMM cards, for memory cards. Okay, so it just depends on your motherboard, and later we'll talk about how you can determine which memory cards your motherboard wants to have in it. And then there's disks. And disks, there's basically two types of disks as well. There's EIDE disks, which stands for Enhanced Integrated Device Electronics. And then there's SCSI disks, which stands for Small Computer System Interface. Generally, SCSI disks are faster than EIDE disks. They're also generally more expensive. So if you're just talking about your home computer, EIDE disk might be the way to go because it's cheaper. And the performance of an EIDE disk could be perfectly fine for a home system. All right. Then for other stuff, there's input devices, and certainly you're going to have a keyboard and a mouse. You should probably have a 3-button mouse for Linux because there's a number of operations in Linux, a number of interfaces that use all 3 mouse buttons. Okay, you can usually emulate that middle mouse button by clicking both mouse buttons on a 2-button mouse, but you might as well save yourself the hassle and get a 3-button mouse because they're, like $9.99 or something. They're not that expensive. Okay, so there's keyboards, mouse. There's also, cameras and microphones and graphic tablets and all sorts of other things. And a lot of these things are supported by Linux. Again, we'll talk later about the various brands of each thing that is supported, and I'll show you where you can find out all that kind of stuff. And then there's network devices like network cards and modems and things like that. Generally, network cards are Ethernet cards. Most networks that you're going to hook up to nowadays are Ethernet networks. And 99% of all Ethernet cards are supported by Linux. So that's one where Linux has nearly full coverage. Linux has support for older networks, like if you're on some local talk network. I guess I'd be kind of surprised if you're on some local talk network, but if you are on some local talk network, there is cards and device drivers for Linux to make your Linux computer work on that local talk network. Then there's video stuff like monitors and video cards. Pretty much every monitor will work with Linux. You just need to know the horizontal and the vertical refresh rate for the monitor. You can determine that, in the manual for the monitor. If you lost that or you never got it or something, then you can look it up on the vendor's website and determine the maximum horizontal and vertical refresh rates for the monitor. And then there's video cards. Now, not every video card is supported by Linux. If you don't have the right video card, you can still use text mode in Linux, but that's not very satisfying. You're going to want video mode. You're going to want X windows to work and all the graphical interfaces to work in Linux. So make sure you have a supported video card, and again, we'll talk about that a little bit later. And there's audio stuff like speakers and sound cards. And again, some subset of the sound cards will work in Linux, and we'll talk about which ones are actually supported later. But Linux doesn't need any of that stuff. Linux doesn't need any audio cards or speakers to work fine. It'll work perfectly fine without that stuff. So next what we'll do is we'll talk about where you can get information about what things are supported by Linux. Let's open up a Mozilla web browser, and what we'll do is we'll look out on the internet for information about Linux hardware compatibility. So what I'm going to do is let's go to Google, the search engine Google here, and we'll go to google.com and we'll type in Linux hardware compatibility. Okay, if I can spell it right, compatibility. Okay, so we go to Linux hardware compatibility, we search for that, and there's all sorts of information out on the internet. What you have to be careful of is for outdated information. Actually, this first page here is quite outdated. I looked at it, it's a couple years old, so I don't want to go there. But like redhat.com maintains their own list of hardware compatibility for stuff that they know works with Red Hat, and what's nice about this is a pretty authoritative list. Red Hat tests it, and they make sure that the hardware works with their system. So you can be pretty sure that if they say it works on Red Hat, that it's going to work on Red Hat. Okay, and that's nice because a lot of the other sites are just user supported sites. They're just user reviews and things like that. Like if we go to the Linux hardware database, which is lhd.zdnet.com, and we go to the Linux hardware database, this is all user reviews, but it's pretty comprehensive. Down here on the left hand side, there's a bunch of categories for various devices. Everything from CD burners and cameras to scanners and TV and video cards is in this list. And if we just go to one of these, let's just go to CD burners, you'll see a list of model numbers and manufacturers, and there's also ratings. Down here on the right hand side you can see ratings for the various products. Okay, let's just click on one of these products that has a 5 rating, one of these Acer CD burners, and basically you'll get a little bit more information about what the user thought about the product. You'll also get a link to the product's spec sheet on the actual website of the manufacturer. Another thing you get is just some resources at the bottom that are not necessarily specific to that product, but they're just general resources. So if you're going to buy a CD burner, it gives you an idea of what you have to go through to get a CD burner to work in Linux, and maybe that'll help you decide which CD burner you want to choose. Okay, let's go back to Google now. And another website that's out there is linuxhardware.net. Now this website, again, has all sorts of information. It has forums about various devices like audio cards, video cards, USB devices. Linux is getting more USB support every day. So that's a good place to go for if you're trying to find out information about a USB device. Network cards, things like that. Actually, LHD at zdnet.com also had discussion boards on this sort of stuff. And this is a good resource. You know, if you're going to buy something new for your system, it's good to ask people and see what they thought about it. If everybody says, "Oh, that was a pain to install," then you probably shouldn't use it, right? Because if they found it to be a pain, you're probably going to find it to be a pain as well. Now, one thing that linuxhardware.net has on it is Linux-friendly hardware vendors, and from these guys, you can get full systems that have Linux preloaded and that kind of stuff. So let's click on that and see what we get here. Basically, what this says is, full systems. When you see full systems, you'll see you're getting vendors that sell complete Linux systems. And that's kind of nice if you're new to Linux and you just don't want to have to go through and order this sound card and this video card and this network card and this motherboard and put it all together. If that's not your style, if you just want to buy something completely ready-made, then come to this site and look down here and price shop for a new Linux system for yourself. Now let's talk about some more hardware specifics. I know I just showed you that website to look up various hardware and see if it's supported by Linux, but I just want to give you some more information to guide you through this process. So first let's talk about the CPU. Now Linus Torvalds originally wrote Linux on an 8386 processor, and this is an Intel processor. Okay, and you say this 8386, and the whole family of processors after this are compatible with the 8386. There was the 8486, there was the Pentium, there was the Pentium Pro, there was a Pentium MMX there for a while. That was a short-lived one. It was like the multimedia Pentium, and there was all sorts of other ones that came after this. Basically, all of these things are compatible with the 8386, so they'll all run Linux perfectly fine. And practically every version of Linux that's out there is going to run on the Intel chips. Then there's the Intel clone chips. AMD is one vendor, and they have the Athlon chip as well as other chips. And all of these chips, I might as well just throw them in this box too, because these are all Intel compatible, even though they're not manufactured by Intel. So you might ask yourself, why would I want any other processor besides these if these run Linux so well? The only other reason might be some performance reasons. There's the Alpha processor out there that's owned by Compaq now. There's the Spark processor that's owned by Sun. There's the PowerPC processor that was developed by Motorola and IBM. And basically all of these processors are not in the Intel family, and the Alpha processor and the Spark processor in particular are more high performance processors. If you're doing scientific simulations or real number crunching applications, the Alpha processor and the Spark processor have proven to be faster processors than the Intel family processors. And we're not going to get into the reasons why there, but just know that they're faster for floating point computations, like real number computations instead of integer computations. Okay, so if you're doing that sort of number crunching activity on your workstation, the Alpha and the Spark might be worth the extra money. The Intel and the AMD processors are definitely going to be cheaper than the Alphas and the Sparks, but like I said, these are just a little bit more high performance processors. Then there's network cards. Now, typically when you hook up to the network, you're on the Ethernet. You might be hooked up to either like 10 base T wire, which just means like 10 megabits per second, 10 million bits per second, or you might be hooked up to the newer stuff, which is 100 base T wire, and that's like 100 megabits per second. Okay, so there's the two types of wire you could be hooked up to. You could have two different types of Ethernet cards too. You could have the older ISA cards, which stands for Industry Standard Architecture, okay, or you might have the newer PCI card, which stands for Peripheral Component Interconnect. Now, if you have a choice between these two cards, go for the PCI card because it's got a higher bandwidth than the ISA cards. Especially if you're hooked up to 100 base T wire, ISA tops out at 64 megabits. So even if you were hooked up to the 100 megabit wire, you're not going to get the full bandwidth because ISA is going to be the bottleneck there. The ISA card is only going to go up to 64 megabits. Whereas the PCI card will realize the full potential of the 100 base T wire. Okay, and then otherwise we've got memory and motherboards, and we were talking earlier about the memory options. There's SIM and there's DIMM, which stands for single inline memory module and dual inline memory module. But once you get past that classification, there's tons more classifications for the type of memory. And basically all the modern memory out there spawned off of DRAM, which stands for dynamic RAM. And I'm not going to get into the specifics of what dynamic RAM is versus undynamic RAM. Take some electrical engineering course if you want to see that. That's pretty detailed stuff, and I don't really understand all the different differences between all the various DRAM. There's various DRAM. There's FP DRAM, which stands for fast page DRAM. There's EDO DRAM, which stands for extended data out DRAM. There's DDR DRAM, which is like double data rate DRAM. I mean, there's so many acronyms here and so many types of DRAM. Basically, what you need to know is to go to your motherboard manufacturer's web page, or if you have the manual for your motherboard, open that up, and it'll have in there specifications for what kind of memory module should go into the motherboard, and also what types of DRAM should be plugged in as well. And a newer version of DRAM might come out tomorrow. And who knows what it's going to do, but it might work on your motherboard for a while. It might start giving some errors. The kinds of errors that the RAM's going to give are going to be really fatal errors. They might crash your computer, cause applications to crash. They're going to be practically undetectable. And so stick to your motherboard's manufacturer's recommendations for the type of memory to run on your motherboard. Okay, and you'll just have far more stability, and you'll have less worries about compatibility issues there. And finally, there's video cards. And basically, the most important aspect of a video card is how much memory it has on it. And this memory is independent from the memory we're talking about up here. It's memory that's actually on the video card, and that memory on the video card is specifically for drawing your screen. So ideally, you want your video card to have enough memory so that your complete computer screen can fit in that memory, so every time it refreshes, it's just refreshing from the video card's memory. And if you have 8 megabytes of memory in a video card, you're set. I mean, you've got enough memory for like 32-bit color and a large resolution screen, and all that will still fit in 8 megabytes of memory. And basically everything else that we didn't mention here, like keyboards and mouse and sound cards and who knows what else, is pretty much supported by Linux. For super specialized things like scanners or USB devices or I don't know, video acquisition boards or whatever you've got, look on those web pages that I pointed you to find out specifically if those devices are supported by Linux. Talking about hardware compatibility reminds me that in the last video I told you that I would show you how to determine your Linux kernel version number. So we'll do that now, and while we're doing that we'll also talk about library version numbers and that kind of stuff. So the easiest way to determine your kernel version number is just to type kernel version at the command line, and you do that and you get the version 2 and the major version number 4. So that gives you the basic information. If you need to know that third digit too, that minor version number, then what you can do is you can do a listing on the /boot directory, and in the /boot directory is the Linux kernel, and it's right there. It's called VM Linus, and it has these numbers after it. And the numbers after it, 2.4.7, is the version number of your Linux kernel. Now the reason you might need to know this is just because there's some sort of compatibility issue that you're trying to resolve. In the Linux 2.2.18 kernel, I think that was the first Linux kernel that had USB support. So you would know if you wanted to hook up USB devices to your system and you had an older kernel than 2.2.18, like 2.2.10 or something, you would have to upgrade your kernel so that you could have USB support. That's the kind of stuff you'll learn by looking at the kernel version number. Now for libraries, one of the places you can look is in the /lib directory. In the /lib directory there's a whole bunch of files. We'll just do an ls, and there's going to be a whole bunch of files that'll scroll off the screen. We'll just look at some of them, and then we'll talk about how to see all of them in a second. So we do an ls on this directory, and you can see there's a whole bunch of files here. Here's the libc libraries, and you can see it's version 2.2.4. This library is used by a lot of different software in your system, and there's the version number. If you wanted to see everything in this directory, what you can do is you can do an ls, and then you can pipe it through the more command. Now this vertical bar is called a pipe because the output of the ls command is flowing into the input of the more command. All right, and basically, you know what the more command does. Remember, it just displays text files one page at a time. All right, and we know what the ls command does. It displays all this directory information. So what's going to happen here is think of all this directory information. Think of this as just a big text file. So that text file now is going to be displayed by more one page at a time. All right, that's what the pipe command does. So we'll hit enter here, and now you can see the various stuff, and we're just seeing one page of stuff in this directory. I hit spacebar, we're seeing one more page of stuff. And then I can even search in here. If I hit that // like we did in VI, I search and I look for libssl or something. Maybe I'm looking for one particular library. And I do that, and then I find some libssl libraries down here. All right, so that's how you would look through the directory for some particular library. Another way that you could narrow down what's listed by ls is you can do an ls and say I'm looking for libc libraries. So I do an ls and I say libc star. All right, now I hit enter there, and only the files that start with libc are going to be displayed. The star says anything at all can come after libc, even nothing. Even if there was a file called libc, it would be listed here, but the star will match anything at all. Okay, so everything that starts with libc is displayed by this ls command. That's another nice way to narrow down what gets displayed by ls if you're looking for something in particular. All right, another place that that libraries reside is in the /user/lib directory. So you could go over there if you're looking for some particular library. Now, in a couple videos down the road, we're going to talk about installing software and software's dependencies on various libraries. And in that video, we'll talk about what to do if you go to install some software and you don't have the library for it. We'll talk about how you can resolve that dependency so that you do get that library so that you can install that software and it'll work correctly. But we'll save that for a couple videos down the road when we talk about software installation. One of the last things I want to talk about in terms of planning our installation is planning out a disk partitioning scheme. Let me explain what a disk partition is first. So here's a representation of your disk, and you can partition the disk. Basically all you're doing is slicing it up into pieces like this, something like that. Okay? And you might look at that and say, well, geez, that looks like the way my brother sliced pizza when I was a kid. That doesn't look very fair. But that's okay, because a different piece of the file system is going to reside in each of these partitions, and those different pieces of the file system are different sizes, so the partitions should look like this. They should look somewhat uneven. Okay, and the different pieces of the file system that you're going to put into the partitions, remember the /boot directory held all the stuff necessary to boot the system. So that goes into one partition typically. /home holds all the user's home directories. So that could go in another partition. Another partition should be relegated to swap space. Swap space is space that's used by the operating system when main memory fills up. So say RAM fills up and there's a demand for more memory, programs need more memory to operate, then what the operating system does is take some of that stuff from RAM and temporarily writes it out to the swap partition, and that opens up some main memory for that demand, so it can meet that demand, and then later it'll pull the stuff back in from the swap partition into main memory. Okay, so this is just a temporary holding place. Only the operating system uses this. No regular users will ever write to the swap partition. And then everything else can just go here. Typically we represent that as just a slash. So if we specify some piece of the file system or some directory explicitly to go in some partition, that will go there. And if we say slash goes here, everything that's not specified explicitly to go somewhere else will go into this partition. Now you have to guess the sizes of these partitions, and there's a little bit of care that should be taken there. Basically, if I guess a size, say for the home directory, and people, start filling up and start writing files and start downloading files and putting them in their home directories, and just say this whole thing filled up. But say there was still space in some of these other partitions. It doesn't matter, you're out of luck. You can't just take this line and move it over a little bit and say, make that partition a little bit bigger. You can't do that after the fact. You're going to have to back up all the data on the disk, save it off to tape, reformat and repartition this disk, and then copy all the data back onto the disk. So that's a really time-consuming and laborious process, so you don't want to underestimate the sizes of any of these partitions. So let me give you an idea on how big these partitions should be, and then you can work and determine for your particular installation how big and what you want to put in each of the partitions, how big each should be and what you want to put in them. So for the /boot partition, certainly 30 megabytes is enough for that. This isn't going to grow by leaps and bounds. Once you put the stuff into the /boot partition, you might add something to one of the startup scripts or something like that, but certainly 30 megabytes is going to be plenty for anything that you do in the /boot partition. Now the /home partition is going to be a lot harder to measure because that is going to grow from the time when you install the system. If it's just one user on the system, certainly a couple hundred megabytes or 500 megabytes is going to be fine for just a single user system. But if it's got multiple users on it, it could take up 50 gigabytes or 100 gigabytes depending on what the use of the system is by those people. Now the swap space, that should be like 1.5 or 2 times the size of your main memory, of the RAM in your system. So if you've got 128 megabytes of RAM, 256 megabytes of swap space is going to be plenty. And then everything else can just go in here. So however big your disk is, if you've overestimated the size of this home partition already, just put the rest of the disk space for this extra partition here for everything else. All right, so there's a basic simplistic scheme here, but you don't want too many partitions because then you're going to be more likely to run into this problem of filling one of them up, and then you're going to have to go through that whole process of backing everything up and copying it back again. So just stick with 4 or 5 or 3 or 4 or 5 partitions on your disk. And in Red Hat, when you do a Red Hat installation, there's two standard installations in Red Hat. There's a server installation and there's a workstation installation. And for those installations, you can actually have the installation program guess the partition sizes for you, and that'll do a pretty good job. It'll look at your disk and determine how big various things should be, and it'll do a basic partition scheme for you that looks something like what I've just drawn. Okay, but if you do a custom installation in Red Hat, and some other versions of Linux, you're going to have to do this all the time. There is no like standard installations that will guess the partition sizes for you in certain versions of Linux. If you do a custom installation, or you have one of those versions of Linux where you're going to have to guess, and you're going to have to make these choices about how big each partition should be. And like I said, just overestimate. And disks are so big nowadays, you're going to have plenty of room to overestimate all these partition sizes. Now maybe you're asking yourself and you're saying, well, can't I just get away with one partition, just like one giant partition, then I don't have to worry about any of these boundaries or anything like that? Well, I mean, you could, but there's certain circumstances where you're going to have to partition, like if you have multiple disks. If you have 2 disks in your computer, you can't have just one partition. You're going to at least have to have 2. But there's other reasons, good reasons why you want to partition. One of them is overrun protection. So say you've got some partition here set up for your home directory, and somebody's written some program that's writing to a file, and they leave for the night and they leave their program running, and say their program just goes out of control. It's not working at all the way they thought it was going to work, and basically say the program just keeps writing to this file, and eventually it just fills up the entire home partition. Well, that's going to be a natural barrier to stop that program from working. It's going to try and write the file, it's going to start getting errors, and maybe the program's going to stop. At least it's going to stop eating up disk space because that partitioning barrier is just going to stop it from writing to that file. So there's a natural barrier, and then that way it's not going to eat up and start taking space from critical system stuff like the swap space and other things that are on this disk. And if you start eating up space in those critical areas, maybe the computer's going to crash. At least this is going to keep the computer up, even if nobody can write to their home directory because it's filled. At least the computer's not going to crash, and the various servers are going to be able to operate, that kind of stuff. Okay, so that's one reason. Another reason is just for easier administration. Occasionally when disks, after a while, you'll use a disk and you'll read and write files, and a disk will get fragmented. Basically what that means is that the open space on the disk is scattered around the disk, and that makes, it just makes things less efficient. So then you go in as a system administrator and defragment the disk. Well, certain sections of the disk you could make read-only, like the /user directory, for instance. If you made that its own partition, you could make that basically a read-only partition because it's just got a bunch of software and stuff like that. And so you know that part of the disk can't be fragmented, because the only time things get fragmented is when you read and write and delete stuff. And then the open space starts getting scattered around. So what that would cause you, or what that would allow you to do, is if you had one section of the disk that was read-only, when you go to do your defragment, you're only going to have to defragment some piece of the disk, and that's going to make the defragmentation process faster and just easier for system administration. Okay, so there are some reasons why you want a partition. Of course, you could just have one giant partition on your disk, but if you had 3 or 4 partitions, you're going to get the benefits that I listed here, and it's really not going to be that much of a hassle or that hard to guess the sizes of those partitions. And the last thing I want to talk about before we wrap up this video are the options that you have for a file system on your computer. The file system is like the underlying organizational structure that the computer uses to keep track of where all the data is on your disk. The most standard or most common file system that's out there today in Linux is the ext2fs file system, which just stands for the second extended file system. And this file system is completely robust, it's fully functional, it's been well tested over the years, and this is, like I said, the most common file system that's out there. The only drawback to this file system is in the case of some kind of a power outage or some kind of a severe crash or something of your system. And then when the computer comes back up, the ext2fs file system wants to verify the integrity of the disk, and this could take many minutes to happen. And that's a problem on like some kind of critical server or something. You might not be able to wait that 5 minutes that the computer is coming back up and verifying the integrity of the disk. That 5 minutes is just too long to wait. So in response to that, people have written journaling file systems, and the Riser file system is probably the most popular of these. It was added to the 2.4.1 kernel of Linux. Okay, and a journaling file system, basically what it does is it keeps track of all the files that were open and all the things that were happening on the disk, and then if in the case of some power outage, when it comes back up, it knows which parts of the disk to check. It doesn't have to check the entire disk, and it knows which parts to check and verify for the integrity of the disk in those certain areas. Okay, so that's why a journaling file system can come up much faster, just in a matter of 10 seconds or something. The verification of the integrity of the disk can be done because it knows exactly where on the disk to check. Now, other journaling file systems that are out there are the ext3fs, which is an extension of this one. There's journaling file systems being written by IBM and Silicon Graphics that will be compatible with Linux. Okay, so that's the journaling file systems. One last thing I want to mention here is just to make sure you understand what this kernel version number means. The first number in here is the major release number. Okay, and this just says that it's major release number 2. Okay, the second number here is very critical. This number, if it's an even number, like if it's 0, 2, 4, 6, 8, then that represents a stable kernel release. If that's an odd number, then that represents an experimental kernel release. And you should not be running odd kernel numbers. If that's an odd number, you should not be running those kernels on your computer because they're experimental. There's going to be lots of bugs in them. They're still being tested out. The only reason you'd want to do that is to try out some new feature or something like that that experimental kernel has that the stable kernel before it didn't have. And then finally, the last number here is the minor release number. Okay, so when I said the Riser file system was on 2.4.1 kernels, it'll be on all the kernels after that as well. So 2.4.2, 2.4.3, 2.6.0 is after this one, and so on. You see how this works now. Now, what I want to make sure you understand is that there's this kernel release number, this kernel version number, and there's also distribution release numbers. Like Red Hat, might be on to version like 7.2 or something like that. That has nothing to do with this kernel number. There is a specific kernel that Red Hat 7.2 uses, but the 7.2 is not the kernel version number. So make sure you understand the differences there. This is just, the 7.2 release of Red Hat, 7.0, 6.8, 6.6. They could have all used the same kernel number. I don't know exactly what kernel numbers each Red Hat version uses. We'll talk later about how to determine what kernel you're using when we do the installation. All right, well, it's time to wrap up our last nugget on installation planning, and in the next nuggets we'll be actually doing an installation. So in this nugget, we talked about the hardware needs of your computer, and that really depends on the purpose of the computer. We talked about hardware compatibility and how to determine hardware compatibility for Linux. I tried to point you to some websites and some resources where you can find out that information. And then we talked about partitions and how to partition your disk and determining the various sizes for the different partitions. And finally, we just talked about the different file systems that are out there and what you should use for your system if it's some sort of mission critical application. Well, I hope you found this nugget informative, and thanks for viewing.